Okay, so let's do our first example here. And this is going to be for finding the area between two curves. Okay, so let's say that we're bounded from above by this function. We're bounded by below on this function, and our closed interval that we're interested in is from 1 to 4. Okay, and so we want to find the area of the region bounded by this. Okay, so now we're going to use the theorem and set this up. So we know that the area bounded by this region is going to be the integral from a to b of f of x minus g of x dx. And so we're going to fill this in. So a is 1, so it's going to be the integral from 1 to 4, right? And it's going to be what? X minus 4. Let's do this. So it's going to be x minus 4 minus g of x, which is 3 minus x over 2 dx. Okay? So now all I'm going to do is I'm going to simplify this and then integrate. So this is going to be the integral from 1 to 4. And so I'm going to distribute. And so this is going to become what? X minus 4 minus 3 plus x divided by 2. So it's going to be minus 4, oops, getting ahead of myself, minus 3 plus x over 2 dx. And so finally, if I simplify this, I get the integral from 1 to 4, x plus x over 2 minus 7 dx. Okay. And of course, this becomes 3 halves x. Right? Oh, I think did I write this down wrong? Ah, yes I did. I'm sorry. This should be plus, not minus. Plus. So the only thing that changes is this should be, oops, 1. Plus 1. Okay. So now at this point all I did was simplify it and integrate it. So now let's integrate. So that means that I'm going to integrate this term by term. So if I integrate this is going to be what? It's going to be x squared, right? And then divide by 2. So this is going to be end up being 3/4 x squared plus x evaluated from 1 to 4. And so now we're going to evaluate. So we're going to evaluate it at 4. So this is going to be 3/4 times 4 squared plus 4 minus 3/4 1 squared plus 1. And then if you simplify all this, right, so this will be 16, so this is going to cancel with one of these, so this will cancel with that one. So then we get 12 plus 4, okay, so we'll get 16, right, 16 minus, this is just going to be 3/4 plus 1. Right? So 3/4 plus 1 is just going to give us 7/4. So minus 7/4. Okay? And if we change this to fourths here, what we're going to end up getting is what? So 16 times 4 is 64. Right? Minus 7. And so the area between the two curves turns out to be 57/4. And these are units squared, right? We don't have any units, but it's area, so it's always units squared. And that's it. So here's one for you guys to do. Again, so more practice. Again, you can email me. Let me know if you have questions or if you want to see if you got the right answers. So let's say we want another boundary region R. And so let's say R is bounded by the graphs f of x equals x squared plus 5. G of x equals x divided by 2 plus 5. Oh, wrong one. Looking at the wrong function here. X plus 1/2. And we want to over the interval 1 to 5. We want to find the region of R. So R is bounded by these constraints, if you will. And so we want to find the area of R. Now, what I would do is make sure you know which function is the top function. So what function bounds it on top and which function bounds the region on the bottom. Okay? You can use your graphing calculator to do that, but again, you got to make sure which one you're subtracting, right? From what? Okay, that's it. See you next time.